Welcome to the first mini lecture in CLS 412, Introduction to Internship. As we will be discussing trauma, traumatic injuries, and mechanisms of injury this week, we need to spend some time briefly reviewing the laws of motion. I appreciate for some it will have been quite a while since high school physics, and for others the thought of physics is not particularly exciting. However, these laws underpin everything which happens during injury, and so it is worth taking a brief moment to review each of the laws. We begin by returning all the way back to our friend Sir Isaac Newton's confrontation with a misdirected apple in the 17th century, a moment that would go on to inspire the theorizing of these laws. What is important to understand about these laws is that they build upon each other. Newton's first law states that every object will remain at rest or in uniform motion in a straight line unless it is compelled to change its state by the action of an external force. Essentially, an object will keep doing what it's doing until something makes it stop. The second law essentially explains how the velocity of an object changes when it is subjected to an external force. When it comes to trauma, the acceleration or speed is the key determinant of injury rather than mass. Finally, and perhaps the most well-known law, for every action, there is an opposite and equal reaction. This helps us understand why internal injuries occur without obvious external signs of significant injury. Here, we will take the example of a common situation in paramedic practice, a rear-end motor vehicle collision, and apply the laws. The driver, too busy recording a TikTok, crashes into the back of another car. The car strikes the back of the other car and comes to an abrupt stop. However, the driver continues to move forward until they, too, are impacted by an outside force, such as the airbag, seatbelt, or steering wheel. This is Law 1. As we remember, because velocity and not mass determines the significance of injury, safety equipment like seatbelts and airbags are designed to slow, rather than stop, the body, compared with the steering wheel's unforgiving structure. Slowing the velocity supports reducing the severity of the injuries. Law 2. Say the driver does not have any safety equipment. They fly into the steering wheel and their forehead strikes the windshield. The impact of the body bends the wheel and cracks the windshield, producing an opposite force to the skull, brain, chest, and abdomen. This is the third law in action. For every action, such as the body striking the wheel or windshield, there is an opposite and equal reaction. When you're ready, head on to the next video discussing mechanisms of injury and injury patterns.